In this video, we'll look at areas of composite shapes. So composite shapes are just two or more simple shapes put together, and the area is the space inside that 2D shape. It's measured in centimeters squared, meters squared, kilometers squared, etc. And the way you can remember this is that the exponent on the units is a 2 or a squared, and we're working in 2D space. It's a 2D shape. Compare this with perimeter that's measured in kilometers, meters, centimeters, inches, and just the distance around the outside. So think of perimeter as the outside, the fence, and the area as the inside, the carpet. So let's look at finding area by adding and by subtracting. So first, let's divide up this shape into two rectangles. So we're going to call this rectangle area 1 and this rectangle area 2. And we want the space inside. So we're talking now about the space inside each of those rectangles. So the first one actually, I guess, is a square. So area 1, to find the area of a square or rectangle, we just multiply the length times the width. So 9 times 9 is area 1. And that would give us 81 meters squared. And then we need to find area 2. Area 2 is 3 times 6, which is 18 meters squared. And our total area, we just add area 1 and area 2 together. So 81 plus 18 gives us 99 meters squared is the total area. So that's how we find the area of a composite shape, by adding. Now we're going to look at how to do that by subtraction. So I'm going to erase these lines, and I'm going to now look at the outer rectangle here. I'm going to find the area of that, and then I'm going to subtract this small square from the corner. So let's see how we would do the total area with subtraction. So our first one then, let's just highlight this big rectangle, and we're going to call that area 1. So area 1 is 9 times 12. 9 times 12 is 108 meters squared, so 108 meters squared. And then area 2 is the small square up here. So we're going to take away 3 times 3, or 9 meters squared. So now we have our total area is 108 minus 9, which gives us 99 meters squared. The same answer. So in most cases, you can either add to find the total area or subtract to find the total area. Sometimes one way is easier than the other, so you get to pick. Let's look at one with more complicated shapes. So we're actually going to go down and do this one with the circle cut out first. Now here, you have to use the approach, I think, of taking the big shape, the big rectangle here, and subtracting half of a circle. Okay, so we're going to look first for the total area of the rectangle that's 5 by 15. We'll call that area 1. And then we will subtract off the area of the circle, and we're half circle, and we'll need a formula for that. So area 1 is just length times width, 5 times 15. 5 times 5 is 25, plus 5 times 10 is 50, so we're looking at 75 meters squared. And then we need a formula. This would be given on a formula sheet. The area for a circle is pi r squared, so we need to use this formula here, and that would be given. That's for a full circle, so we want half of a circle. So area 2 we are going to take pi times r squared, which means pi times r, and then we're going to divide it by 2. So you're going to see the formula written as pi r squared, but that means pi times r times r. And in this case, we need to divide it by 2 because we're talking about a half of a circle. So pi is approximately 3.14. Our radius is halfway across the circle through the center, or half of the diameter, which is all the way across, and half of 5 would be 2.5. So times 2.5 times 2.5, and then we have to divide by 2. So let's get our calculator there. So we need 3.14 times 2.5 times 2.5, and then we need to divide by 2. So 9.8125 9.8125, and that's meters squared. So now my total area we're going to find with subtraction. So we're going to take the big rectangle, which has an area of 75 meters squared, and we're going to subtract the half circle, which has an area of 9.8125. So we should end up with approximately, well, 75 minus 10 would be about 65 is what we should get. So let's use our calculator to help with that one. So 75 minus, it was 9.8125, 65.1875, which we predicted 65 is the approximate answer, so that makes sense. So 65.1875, 65.1875 meters squared. So that's how you find the area of a shape through subtraction. Now let's look at one we're going to find the area of the shape with addition. So I'm going to divide this up into two shapes again. I'm going to start with a rectangle over here. That's 4 by 15. And then I've got an isosceles triangle over here. Now, the problem is that I know the slant height. So I know this side over here, but I need a formula to find the area of a triangle. The area of a triangle is base times height. Remember, there's a times in there. We just don't write it. Divided by 2. So the base is down at the bottom. So if I redraw this triangle here, let's make it nice and big. That did not work. Hold on. Okay, so I'm going to redraw the triangle. The height is actually the vertical height here. These sides here, these are the side lengths. This is 3.5 and this is 3.5, but you don't see that in this formula. So we don't actually need the 3.5. We need the base. The base we can find because the width of this rectangle is 4, so this would also be 4. But we need to do some work to find the height. Well, remember back to Pythagorean theorem. If I know 2 out of the 3 sides in a right angle triangle, which I have a right angle triangle here, I have 2 actually put together to make that isosceles triangle. If I know 2 out of the 3 sides, I can find the missing side. So let's look at just half of that isosceles triangle for a moment and see what we can find out. So if I've got this over here, this is like the top half of that triangle. If all the way across is 4. Halfway across will be 2. I need to find h here in my picture. And I know that this is 3.5. So remember, the hypotenuse is always across from the 90 degrees, the right angle. And it's the c. So c squared is going to be 3.5 squared. Let's write that number over here. So remember, that's like finding the area of this big square over here, 3.5 times 3.5. So let's find out what 3.5 squared is going to be first. So this is the length c here, c squared. We need a calculator for that one, so we're going to do 3.5 times 3.5, 12.25. Okay, so we've got c squared is 12.25 centimeters squared. And I need the 2 to be squared as well. This I'm going to call b. B squared is going to be 4, 2 times 2. So b equals 2, and b squared is 4. And you'll recall that to find h squared, when I'm looking for one of the sides that's not the hypotenuse, I have to take c squared, 12.25, and subtract off the smaller side squared that I know, so minus 4. And that's going to give me my h squared, or if you want to think about it as your a squared. So 12.25 minus 4 is going to give us 8.25. Oh, I'm running out of room here. And then we need to take the square root of that to figure out what h is. So h is going to be the square root of 8.25. So let's grab our calculator. So square root. Square root 8.25. And we end up with 2.8723. 2.8723. 8 points. I forgot what it is. 2.8723. 2.8723. 2.8723 centimeters. Okay, so you have to start by using Pythagorean theorem to figure out the missing height. So I'm going to get rid of some of this stuff because we have a lot going on here. And I'm just going to fill in the picture here. So I've got the height now is 2.8723. I know the base is 4 and the side length is 3.5, which I didn't need. So I've got the area of the triangle is the base, which is 4, times the height, which is 2.8723, and I have to divide that by 2. So let's get my calculator out here again. So 2.8723 times, times 4, and then divide that by 2. So 5.74, approximately 5.74. So 5.74 centimeters squared is the area of the triangle. And we can make that a little bit smaller now to give ourselves a little bit more room. Make that a little bit smaller. There we go. Okay. And then with a different color, we're going to find the area of the rectangle, which will be a little bit easier. It's just 4 times 15. 15 times 2 is 30. Times 2 again is 60. So 4 times 15 is 60 centimeters squared. And our total by addition, our total area is going to be equal to 60, the area of the rectangle, plus the area of the triangle. So we end up with 65.74 centimeters squared. So that one's quite a bit trickier because, again, you need to rely on using Pythagorean theorem. Pythagorean theorem is going to come up whenever you know 2 out of the 3 sides in the triangle, you need to find a missing side. So in this case, we had to use c squared. We knew b squared, and we had to find a squared, which was our height squared. And once we found that height, we were able to put that into our area formula.